Hello there, back with Booklet E, part 2. We're going to focus in this little video, it's going to have a main focus on factorizing. So again, hoping you can see these. I'm relying on the fact you can. But we've got 3 or 4 things here. Factorizing quadratics with a equal to 1. Don't get confused with that. By a, I mean what's before the x squared. Okay, so there'll be an x squared term. I think of that as being ax squared. Well, I'm looking at 1x squared in this case is plus bx plus a number on the end c. Okay, we'll quickly re-mention, although we did this in video 1, the difference of 2 squares, and we'll move on to factorising harder quadratics where a is not equal to 1, bringing in a little bit of problem solving and some simplifying fractions. We may also get onto algebraic fractions because there's an element of being able to factorise a quadratic in there, and if we can get that far, great. We leave these last 3 to part 3. Okay, quick reminder before we get into the booklet. I used this sheet in video 1, but let me quickly just mention it again. 4 types of factorising: 1 bracket, difference of 2 squares with 2 brackets, easy quadratic, 2 brackets, harder quadratic, 2 brackets. I always kind of work in reverse to work out which one I'm doing, okay? So I'm first of all asking myself the question, is what I need to factorise a quadratic equation? Can I see a quadratic equation in front of me? Have I got some x squareds, some x's, and a number like this or like this? If I do, okay, then I'm going to employ one of those methods. Now there is a slight difference between this method for the harder ones where there is a number here, like 2x squared or 3x squared or 4x squared and so on, or this one where there isn't. So what I've got is 1x squared. Okay, this is a lot easier than this, but once I've eliminated whether this is a quadratic that I'm asked to factorise, well, these methods are out of the window, and then I'm looking at these 2. And I would next go here and go, okay, if it's not a quadratic, is it a difference of 2 squares? Is it a square number, take away a square number? Okay, for example here, what I've got here is d squared take away, now I was going to give you just c squared there, okay, d squared take away c squared. D times d, take away c times c, but we also need to look for square numbers. For example, 4 being 2 times 2, or 9 being 3 times 3, 16, 25, 36, and so on. If I've got any squared letters or square numbers, and one is being taken away from another, right, that will be the difference of 2 squares. If they're not square numbers or squared letters, like d squared or c squared, then you can ignore this one. But the rule here is whatever's being squared here, in this case d times d, and whatever's being squared here, in this case 2c times 2c, the 2 times 2 giving me 4, and the c times c giving me c squared, okay? Go into brackets, one with an add and one with a take away. So you'd have d plus 2c, d minus 2c. You'll see a couple of those as we get into the booklet. And then once I've eliminated, no, it's not a quadratic and it's not a difference of 2 squares, all I'm left with is just to take what's common out of both things and leave myself with 1 bracket. In this case, I've been able to take the highest common factor, 3, out of here. I've also been able to take an x out because this is x squared and this is x, and my bracket has left me with x plus 5. Okay, into the booklet. Let's have a look at particularly some of these type 3 and type 4s. And we're picking up this video on, although the pages aren't numbered, I've numbered them. So I am on page 6, which looks like this. This is a nasty place to pick up, but let's do it. Okay. I looked at this. Okay, it said fully factorise the expression, and I thought, okay, it's not a quadratic, definitely not. It's not a difference of 2 squares because that's c cubed, so that's not a square number, although there's a takeaway. It's not 2 squares there, so this has to be a type 1. This is a single bracket, so what can I take out? Well, this is c times c times c. This is c times d times d. Well, there's a c in both, so I take him out. There he is. What am I left with? C times c squared gives me c cubed, and c times d squared gives me cd squared, and the minus I've put there. On first inspection, I thought that was it. It was only actually when one of you guys pointed out to me that this was a 3-mark question, it made me consider, okay, what actually have I got left inside the brackets? Well, if you look at it, it's not a quadratic, but it is a square number, take away a square number, so I can refactorize what's inside the bracket, and I've actually labelled up like a difference of two squares. This one being c times c, this one being d times d, right? So my factorization of this would be c plus d, c minus d, and then don't forget him as well. He starts there, okay? Didn't like that one. Let's move down. Actually, let's miss out that next question. We'll come back to it, and let's try another one of those. Come back into... There we go. Focus at the bottom of the page. Okay. Looking at it, not a quadratic. Looking at it being a difference of two squares, because I've got the x squared minus the y squared. However, neither of those numbers are square numbers. 12 is not a square number. 27 is not a square number. So it's got to be a type 1. Okay. What's the biggest number that goes into 12 that also goes into 27? A little bit of thought, and you'd come up with the fact that's 3. That is all that can come out of there, is 3. 3 times what gives me 12? 4 with x squared. 3 times what gives me 27? 9 y squared. Put the minus in there. But it's a 3 marker. Surely I haven't done enough for 3 marks. Again, look at what's left. Get my red pen. This time, yes, I've got my x squared take away y squared, but the number before the x squared is a square number, 4, and the number before the y squared is also a square number, 9. Okay, 4x squared is 2x times 2x, and 9y squared is 3y times 3y. So to factorize this using the difference of two squares, it'll be in the first bracket 2x plus 3y, and in the second bracket 2x minus 3y. Don't forget this 3, he stays. 2x plus 3y, 2x minus 3y. Okay, hopefully they make sense. Let's go to the middle two. Really don't like these. Okay, again, when I first saw these a couple of years ago creeping in to the papers, my instinct, I guess, was to expand all the brackets. I know it said factorize, but I thought, well, if I expand it all and simplify it all, maybe I'll be left with a quadratic that I can then factorize. And I did, and I got the right answer. So it works, all right? But for 2 marks, that's more. I thought I'd done about 5 or 6 marks work at least there to expand all these brackets, collect it all together, simplify it, and then factorize it. So a little bit of a shortcut. I don't know if something like this will come up, but just something to bear in mind, okay? On second inspection, I realised that this bracket here and this bracket here are the same, e minus 1. Here, this bracket and this bracket are the same, x minus 7. So I thought of e minus 1. I thought, oh, look, let me replace e minus 1 with a letter. So I'm going to let a be equal to e minus 1. I'm going to, anywhere I see e minus 1, I'm going to replace it with a. Okay, this would become 5a squared plus 3a. Right? Now, this can be factorized. Okay, it's not a quadratic, it's not a difference of two squares, so it's a type 1. What can I take out? The only thing I could see that I could take out here is an a, leaving me in the bracket with 5a plus 3. I have factorized that, but now I need to put what a was back in. So where I see an a there, I've replaced it with e minus 1. Where I've seen 5 times a there, I've replaced it with 5 times e minus 1. So both those things have to be multiplied by 5, but not forgetting to add 3 to that as well. That bracket doesn't change. 5e minus 5 plus 3. Well, the minus 5 plus 3 is minus 2 there. It's your second bracket. Nasty. I'll run the same process here just to make sure you understand what's going on. Again, I'm going to replace this bracket with anything you want. I'll call it a. So instead of x minus 7 squared, I'll call it a squared. Instead of plus 2 times that, I'll call it plus 2a. Type 1 factorizing, it's not a quadratic, not a difference of two squares. A comes out, leaving me with a plus 2. But what was a? A was the bracket x minus 7. So instead of u, I'll put x minus 7. And instead of u, I'll put x minus 7. But I have to add 2 on to that bracket. X minus 7, and the second bracket, the minus 7 plus 2. Minus 5, okay? Bear in mind, look, there's 2 of the same type of question there. If you see the part A, you'll see the part B. They might put that question in. It's one just to bear in mind, okay, and have a little look at. Let's move on. let's get into then type 3 questions, easy quadratics as I would call them, okay? What we're looking for here, let's deal with the factorizing bit. We'll come on to the hence solve, okay? The factorizing, we're looking for two numbers that will multiply to give the end number, okay? Or times to give the end number, that will then add or take away to give the middle number, the number before the x. There is no number at the start, that is why we're using this method, all right? It's 1x squared. So times to give minus 18 here, and add or take away to give minus 7. I've seen this before, team, standing for times to give end, add to give middle. Up to you, right? Just to remind yourself. So two numbers, the times to give minus 18, that will add or take away to give minus 7. My combinations, first of all, I'm ignoring the minus and the 18. I'm just coming up with combinations of numbers that multiply to give 18. 1 times 18, 2 times 9, 3 times 6. Then I'm looking at these to work out which pair here could allow me to add or take away to give minus 7. Okay, important that it's minus. Right, and it's the 2 and the 9. Now, if that was plus 7, coming from there, I'd be doing 9 take away 2. But because it's minus 7, 2 take away 9. And basically, that's the factorising done. The 2 goes in a bracket with an x, x plus 2. And the minus 9 goes in a bracket with an x, x minus 9. Now, the question may well just say factorise. Okay? If it does, that's the end. Job done. If it doesn't, and it says hence solve, we have to realise, well, actually, what's happening here is that this times this is equal to 0. Well, for this times this to be equal to 0, one of these things must be 0. So either x plus 2 equals 0, move the plus 2 over, so x equals minus 2, or x minus 9 is 0, move the minus 9 over, x equals positive 9. The rest of this page, or certainly the next two questions, are a chance for you to practice those two. If you want to do that now, and then hit pause and check you've got them right. Okay, notice in this one here, you don't have to go on to solve, factorize only. Then we'll quickly look at the bottom one. Now you can see I've already filled that in. However, let's go through my thought process. I'm looking at it. Is it a quadratic? I've got m squareds, 4m squareds. What I'm missing is an amount of m's. I've got my number, okay, but it's not a full quadratic. So then I'm looking, is it a difference of 2 squares? Well, certainly 4 is a square number, it's 2 times 2. And m squared is m times m. I'm dubious of 289, but because I've got a calculator, I guess I can check if that's a square number by taking the square root of it. And when I put that in my Casio, it tells me that the square root of 289 is 17. So whereas this guy is 2m times 2m, this guy here is 17 times 17, and I've got the minus. So this is the difference of 2 squares. Shortcut, first bracket 2m plus 17, second bracket 2m minus 17. Job done, okay? It could have said, and hence solve equals 0. It could have, okay? So I would have had to go through the process of saying either 2m plus 17 equals 0, or 2m minus 17 equals 0, exactly like we've done above. This would give me m is minus 17 over 2, and this would give me m is 17 over 2. And because 2 doesn't divide into 17, you can leave that as is. Okay, now we move on to the harder quadratics. Alright, now these ones are often accompanied by a problem-solving element. My daughter has just walked in the room. 2 seconds, everybody. I'm on a video. I'll be up in 10 minutes with it. Okay? Unbelievably, she wants me to model a balloon and take her a milk. So we're just going to have a 2-minute break while we make... by the way, I could have done a tutorial on how to make... And there it is, the world's tiniest balloon dog. Looks a bit weird, doesn't it? So we'll take that up to in a sec, but let's just move on with the video. So what's going to happen here is this. Often for the type 4, okay, so where you've got a number before the x squared, you can see there, this is 2x squared minus 5x minus 25. There'll be a problem-solving element, so you'll have to actually make the quadratic, then use factorizing in order to solve it, okay? for example, this one, what we were told in this one is that the combined area of both rectangles is 50. Alright, so the area of the U would be x times x minus 1 in bracket, x times x minus 1. I call that one B. There it is. Okay. And actually, I'll go on and say what I've actually done here then is I've expanded this x times x and x times minus 1. X times x is x squared. X times minus 1 is minus 1x, or just minus x. Then a little bit awkward, I thought, because that is 2x, but that is x. So in total, the length of that is 3x, 2x plus x, which is 3x. 3x times the width, x minus 3. Again, a little bracket to expand. That times that, and that times that gives me 3x squared minus 9x. So the total area in terms of algebra, adding these two up, is 4x squared. And then I've got minus 9x, take away another x, or another 1x, so minus 10x. Okay, but I'm told that the total area is 50. So what I've written here is my formula that I've made, my equation that I made is 4x squared minus 10x equals 50. However, we know in order to solve a quadratic, we need it equal to 0, so the 50 comes over as minus 50, giving me the quadratic I need. Now, I'm not going to show you, actually, a big point here. What they've actually said here is by considering the areas of the two rectangles, show that 2x squared minus 5x minus 25 equals 0. So there, we haven't quite got to that, but you'd have had to spot, hang on, if I half that 4, half that 10 and half that 50, then what I've got is what I need. I then go on to use, down here, my method for factorising this, okay? However, you're going to try, I say this, you can't even see that, hopefully you can now. But if you want to try that yourself and then hit pause here, maybe you can just check your answers. But I will do one for you just to remind you of the process. So let's take a look at the one at the bottom. There isn't a problem solving element. We've got factorise 3x squared plus 10x minus 8. And then we're going on to hence solve it. Okay, this one then, slightly different to type 3, type 4, because of the number there. We start by multiplying the 3 by the minus 8. What's before the x squared, you times by the number on the end. 3 times minus 8 is minus 24. Okay, here's my table. This time I'm looking for two numbers that times to give the end number, but the end number isn't minus 8. We're going to think of the end number as this minus 24. So it times in to make this minus 24. But just like in type 3, we've got to find those two numbers also have to add or take away to give plus 10, which is the middle number. There, plus 10. Okay, now the reason I'm doing this one, it highlights a big issue. Okay, you have to write out all the ways of making 24. 2 times 12, 4 times 6, 3 times 8, and 1 times 24, because whereas these two can't make 10, I could make plus 10 with two things here. 12 take away 2 would give me the plus 10 I need, but also 4 add 6 would give me the plus 10 I need. If there's more than one way of making that, you have to go look back at these and make sure that these make this sign correct, okay? With this one, we'd be suggesting that the 4 and the 6 both need to be positive. 4 add 6. But 4 times 6 is 24. Not what I need. Whereas here, if the 12 is positive, but it's minus 2, that's negative, minus 2 times 12 gives me the minus 24. Which comes from there. So that sign is only important if there's more than one way of making that number. If there's only one way to do it, job done, okay? But if we spot a couple of ways of making that number, just match them back over, put the signs back over onto these numbers and make sure that they give you the correct sign there. Okay, once we know the split that we need, now that we've agreed that that gives them, that's right, that doesn't work. Okay, we'll write this out in full. 3x squared. Instead of plus 10x, we're going to go for plus 12x minus 2x. Okay, then also minus 8 equals 0. Line down the middle. Type 1, factorising of both. Single bracket. What can I take out of here? Highest common factor is 3, but I can also take an x. Leaves me with x plus 4. Need this bracket to be the same as this, so I'm looking for this to be x plus 4 as well. However, the biggest number that can come out here is 2, but because they're both negative, actually I can take minus 2 out of there. These two make my first bracket, 3x minus 2, and then my second bracket is this bracket here, x plus 4. There's the factorising done. The hence solve equals 0. So either 3x minus 2, this bracket, is 0, or x plus 4, this bracket, is 0, giving me the answers minus 2 over to become 2 over 3, and this one plus 4 over to give minus 4. Again, I think this video will probably run out of time, so we'll stop there. I know we've only done 2. I'll give you the answers to the remainder of these, and we'll move on with the end of this video at the end. If only I hadn't had to model a balloon in the middle, we probably could have finished this section as well. But hey ho, see you soon.